Hi all, I am Sini Pulari. I am here to make you understand the fundamentals of one API, and above all, we will also like to know the different value adds that will bring this one API platform will bring back to you. And let's not waste our time and let's dive deeper into this concept of one API. Okay, let's get started. So before moving over to why we need one API, I think we should have a clear knowledge about what are the various programming challenges that we always face. So once we already know that there are a lot of programming languages which are available, and there are a lot of architectures which are available. And the problem which we always face is that we write our code in by using one particular architecture, which might not be compatible with with any other architecture. So we as developers will always end up in the fact that we need to write the code again from the scratch. So this major concern is basically is actually addressed by using this one API cross architecture programming model. So let's so if we think a little bit deep into it, we know that the technological advancements are so quick and it just evolves like anything over the time. So the major thing is that there is no common programming language or common API which we could use, and we can just make sure that it is compatible for every application that we do. So what happens is that there is kind of an inconsistency across the platforms which comes in place, and which acts as a concern and a difficulty for the developers to explore in the way they want, right? So when we think about this, so each platform, say if I'm a developer, I'm coding something using a particular architecture, that platform requires its own unique software investment, and it might not be compatible, even the hardware which I have used, or there would be a diverse set of data centric hardware which is required for that architecture, which might not be compatible with the other ones, right? So dealing with all this, in order to deal with all this, Intel has actually launched this one API cross architecture programming model. So moving and diving a little bit deeper into this one API architecture, so it is supposed to be one unified programming model to simplify development across diverse architecture. Yes, it's kind of a very strict statement, but let's see the diagram, which is actually the stack architecture, which is actually shown near to us. So when we look at here, so let me take the pointer options. Yes, sorry. Okay, so yeah, so when we look at this particular architecture, we could see that there are so many processing units, like CPU could be there, GPU could be there, FPGA. So there could be various kind of accelerators which acts as the zeroth level in this architecture model. And above that comes the one API programming model that we are going to see. It basically has got two parts. One is industry initiative, which we will see in the next slide very fast. And then we do also have this Intel product, Intel product. And upon that, we have this middleware or the framework, so which includes the deep learning architecture or any other frameworks which we use for our specific applications. And upon that, we have this application workloads which needs the diverse hardware, like maybe for the if we want to make it more optimized and enabled for the custom based applications, like scalar, vector, spatial, or matrix applications, we could basically do this. So this is basically the architecture for the one API. So when we look at this, the major thing which we could understand is that it is based on the industry standards and open specifications, and it highly provides you with interoperability. Like we do have the lot of existing HPC programming models, and it is actually inconsistent. It is inconsistent with the existing technologies which is actually already available. So that is a major point or the highlight that I want to talk about. Then moving over to this industry initiative. So let's have more concentration on this yellow line which is actually given to us. So here this mainly talks about the one API industry specification, which basically includes this direct programming and the API based programming. So in direct programming, as we could see here, it is like data parallel C++, and APIs based programming basically includes these libraries. And when we look at this data parallel C++, you could see that it is both the standard based cross architecture language. That means that it is based on C++ and SQL based on the Kronos. And when we look at this APIs, it has got powerful libraries, it has got powerful ABIs, and it helps us to come out with key and domain specific functions. And upon all this, the major highlight which we have to talk about here is that this low level hardware interface. This interface basically helps and acts like an abstraction layer, so we don't have to worry about how it is implemented, how it is actually taking care of your code which you have done in your application. The vendors don't have to worry about it, they just have to worry about their coding, and this low level hardware interface will help it compatible with this and get initiated to the one API industry specification. So as I have told earlier, it is open standard, and it helps to promote the community and industry support, and the most predominantly I have to say that it enables code reuse across the architectures and the code and the architectures which is developed by any vendors. So even though your code is built by any programming language across any multiple architectures, it doesn't matter, right? When you use the one API, it basically helps. You don't have to reinvent the wheel again. Instead, you can reuse it, and it inculcates this code reusability, and you can help not to waste your time again by doing something from the scratch. Yes, moving over to what data parallel C++ is. Yes, it is standards based and it is cross architecture language. And when you look at this architecture which is given here, you could see that it is based on C++, and it has got, as I have already told, it's based on C++ and SQL from the Kronos, and it also includes a lot of community extensions. So moving a little bit deeper into what this DPC++ is, it incorporates a lot of parallelism, productivity, and performance for CPUs, for your CPU or any other accelerators, as it say like FPGA or GPU or anything. And it allows code reusability, and it also allows the custom tuning. So custom tuning for a specific accelerator is possible with the help of this DPC++, and it is open, and it has a cross-industry alternative to a single architecture proprietary language. So as we used to tell, again I'm repeating it, we don't have to worry about what is the programming language and what is the architecture that we have used. Maybe our code is based on CPU, but it could be easily compatible with any other alternative which is already available with the help of this DPC++. And the another thing which we have to say is that it is easier for the developers to learn this DPC++. So you don't have to worry about or scared about how you will learn about this, because it uses the familiar C and the C++ constructs which everyone have learned across, and it incorporates this SQL from the Kronos group, which helps for the data parallelism and heterogeneous programming. So heterogeneous programming, it's as simple as that. You have a application, a code which is written using CPU. You can easily, scale it up to any other accelerators like CPU, GPU, or any other FPGA or any other accelerators. And yes, it has got a lot of community support. It just gets you with a lot of extensions so that you can simplify the data parallel programming, and it is open and cooperative development. It's like there is a continued evolution which is happening to these extensions, which will help you to widen the kind of the extensive applications that you want to do with this one API. And talking about this one API based toolkit, yes, you do have a lot of toolkits available, like you have direct toolkit, API based, and analysis and debug tools. So this one API, this direct toolkit basically contains this one API DC++ compiler and DPC++ compatibility tool, and the most famous and most widely used Intel distribution for Python, and so many in that course. And API based, in that you have got a lot of libraries which are available, and in the analysis and the debug tools you have vTune profiler and advisor, which helps you for offloading and all those similar kind of activities. And yeah, who can use all this? Yes, we as developers can very widely and extensively use all these features and packages and which are there in the toolkit. Yes, what are the major benefits which we get out from it? As I told you, yes, it has got its own compiler, library and analysis tools. It's kind of a one single package which you could do everything for for your code. And another thing is that, you know, DPC++ compatibility tool helps you for the code migration. So what do you mean by code migration? Yes, my code is written in CUDA. Can I migrate it to DPC++? Yes, it is very easily, it could be easily done with the help of this DPC++ compatibility tool. And you have got this famous Python distribution, which has got all the major packages and libraries, scikit-learn, numpy and scipy libraries, which is very widely used for the deep learning and the machine learning applications. And of course, last but not the least, the optimized performance libraries like threading, math, data analytics, deep learning, video and image processing applications, we could very widely use this Intel One API based toolkit. Yes, so as I have covered everything, I think, you know, you would now understand that why One API, this cross architecture programming model could be really helpful for you in your upcoming applications, and why it is important for you to dedicate and, you know, pass it on to others, those who don't know about it. So it's our responsibility to expand and ignite the fire of learning in others by using the technological advancements which we have in our place. Thank you so much. Yes, so now it's the time for the Q&A. Yes, the first question which I could address you is, why should we use this DPC++ and what does it get to me? Yes, so as I have already told you earlier, DPC++ is basically based on the C++ and the SYCL, and it is very easy for you to learn, as it uses the basic constructs from, most of the people would have already learned the structured programming C and C++, the object-oriented programming C++. So we basically incorporate a lot of constructs from C and the C++, so which will help you to learn it easier. And the code migration, which is basically in C++, help you to migrate the code from CUDA to DPC++ by using its compatibility tool. So it's very easy for you to to incorporate this cross architecture programming model by using this DPC++. Yes, the second question is, can you elaborate on the code reuse across architectures? Yes. It's as simple as that. You are writing a code by using one of the architecture, say CPU, but you don't have to worry about, how to integrate and whether it will be compatible, or you don't have to, write anything new from the scratch. Yes, you can do that with the help of this One API, because it incorporates everything that you need. Its stack architecture includes everything that it needs, and it's kind of a one single architecture model which will help you to integrate and make your code compatible with any architecture which is available. So hence we have this One API, which is cross architecture programming model, which is for anything. So it's easier for you to use in your future for any application, and to extend your application to whatever extent you want. So that answers my question. So if you have any further questions, you can always get back to me. So thank you so much for being part of this program. Thank you.